Hey class, we were working on elimination in class, and I just thought I'd give you one example so that you have something on a video that you can use as a resource. Okay, we did a couple problems in class. I'll just throw one more at you here. Let's say we have this equation, negative 3x, negative 3x plus 7y equals negative 16, and we have negative 9x plus 5y is equal to 60. All right, and we're going to use matrices to solve that system. So the first thing I want to do is put that into a matrix, and a 2 by 3 matrix. So we're going to just put in the coefficients, negative 3, 7, and negative 16, negative 9, 5, and 16. And then we're going to try and do some row reductions till we get this to the point where it's a solution matrix, which means I have a 0 there, a 0 there, a 1 there, and a 1 there. All right? And basically what I'm saying is this matrix, 1, 0, x, and 0, 1, y, represents the solution. So if I can get it reduced down to that, then we have the solution. All right? And we're going to do some row operations to get it there. So I need I think I'm going to work on getting a 0 here first. I have a negative 9, and then I have a negative 3 in the top row. I'm thinking that if I multiply the top row by negative 3, and then add it to the bottom row, then I can replace the bottom row with that result, and that'll give me a 0 there where I want it. So I'm going to replace that into row 2. So if I multiply the top row by negative 3, and this is just my notes, I get 9, negative 21, and 48. And then if I put that into if I add that to the bottom row and then replace the bottom row with that, row 2, then I get 9 plus negative 9 is 0. Negative 21 plus 5 is negative 16. And 48 plus 16 is 64. And then the top row, I'm just going to leave. I haven't done anything with that yet. All right. So now I have a 0 there where I want it. I would like this right now to be a 1. And to get that and not change that 0, I'm going to use division. I'm going to divide everything by negative, everything in this row by, I'm dividing row 2 by negative 16. And when I do that, I get a new matrix. Again, the top row I haven't changed yet, but row 2 will now be 0, negative 16 divided by negative 16 is 1, and 64 divided by negative 16 is negative 4. So I now know my solution for y is negative 4. Okay, now the top row, I need a 0 right there. To get that, I have a 1 here, which is kind of handy because I can multiply that by negative 7. So I'm going to take row 2 times negative 7, and then I'm going to add that to row 1 and replace that into the top row, and that'll give me a 0 there. So let me just put some notes here so I know what numbers I'm going to add. Negative 7 times 0 is 0. Negative 7 times 1 is negative 7. Negative 7 times negative 4 is positive 28. So now I need to add those to row 1. And when I do that, 0 plus negative 3 is negative 3. Negative 7 plus 7 is 0. And 28 plus negative 16 is 12. All right, and the bottom row I'm going to leave the same because that's already a solution, so we don't want to mess with that. Now, I have the 0 where I want it in the row 1. I just need to take my row 1 and divide that by -3, and that'll give me a 1 right there. Put that in row 1, and if I do that, I get -3 divided by -3 is 1, 0 divided by -3 is 0, 12 divided by -3 is -4, and my bottom row is already solved. So my solution is -4, -4. And I might want to check that back in the original equation. Right there. -4, -4. Let's see how that works. So, -3 times -4 plus 7 times -4. I'm hoping that's equal to -16. Let's see, that's -3 times -4 is 12 plus -28. That is equal to -16. Happy about that. And the second equation, -9x plus 5y is equal to 16. Again, we're going to replace x and y with -4. That's what we think the solution is. And I'm hoping that equals 16. And -9 times -4 is positive 36. 5 times -4 is -20. And 36 plus -26 is 16. Now I'm really happy because both numbers work, and I use a matrix to solve that system. All right, so there's an example. Hopefully that helps you on your practice. And soon I will show you how you can use your calculator to solve those matrices.